In this lecture, we are going to see the problems based on Laurent series. So this is the problem. Find the Laurent series expansion of f of z equal to 1 by z square minus 3z plus 2 in the region 1 less than mod z less than 2 and mod z greater than 2. And another region is 0 less than mod z minus 1 less than 2. To find the Laurent series expansion, first we need to do the partial fraction of the function f of z. So for that, you factorize the given quadratic, so which is equal to 1 by z minus 1 into z minus 2. To do the partial fraction, write a by one factor plus b by another factor. And take LCM and then simplify. So then you get a into z minus 2 plus b into z minus 1 equal to 1. Now substitute the arbitrary value for z to find the values of a and b. The other way is you equate the coefficients of z constants and so on. Then we get the values of a and b. Here we are going to find the values of a and b by substituting the values for z. Substitute z equal to 2, then what do we get? So b equal to 1. And similarly substitute z equal to 1, then you get a equal to minus 1. So f of z will become minus 1 by z minus 1 plus z minus 2, 1 by z minus 2. Now we are going to expand this as a Laurent series. So we are going to use the binomial expansion of 1 minus z 1 minus x whole power minus 1, so which is nothing but 1 plus x square plus so on, which is valid for mod x less than 1. Now consider the first region. First region is what? 1 minus mod z less than 2. So for that 1 minus mod z less than 2, if you consider the first inequality, that is 1 less than mod z, so which implies 1 by mod z is less than 1. Similarly, if you consider the second inequality, that is mod z less than 2, so you bring this to the to other side, then you get modulus of z by 2 is less than 1. Now consider f of z. F of z is this is mod minus 1 by z minus 1 plus 1 by z minus 2. And here first inequality is 1 by mod z is less than 1. So if you take this z outside, then you get z into 1 minus 1 by z. Similarly, in the second term, if you take 2 as common, minus 2 as common, then you get minus 1 by 2 into 1 minus z by 2. Now you bring it to the numerator, then what do you get? Minus 1 by z into 1 minus 1 by z whole power minus 1 minus 1 by 2 into 1 minus z by 2 whole power minus 1. Now we expand like 1 minus x whole power minus 1, so which is nothing but 1 plus x square plus so on. So similarly here 1 minus 1 by z whole power minus 1, so it can be written as 1 plus 1 by z plus 1 by z square plus 1 by z cube, and minus 1 by 2 is as it is. And similarly here minus 1 by 2 as it is, and then 1 minus z by 2 whole power minus 1 is like 1 plus x 1 minus x whole power minus 1, which is nothing but 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube, and so on. Now simplify further, then you may get this one. Now the second region is mod z greater than 2. So mod z greater than 2 can be written as 1 by mod z less than 1 by 2 is less than 1. Means taking reciprocal on both sides, then you get this equality. Similarly, if you bring this mod z to that side, then you get 2 by mod z is less than 1. Now consider the same function f of z equal to minus 1 by z minus 1 plus 1 by z minus 2. Here 1 by mod z is less than 1, so you take z as common, so then you get z into 1 minus 1 by z. Similarly, in this term 2 by mod z is less than 1, so you take z as common here also, then you get 1 minus 2 by z. So now bring it to the numerator, then you get to whole power minus 1, here also whole power minus 1. Now I expand like 1 minus x whole power minus 1, which is nothing but 1 plus x square plus 1 x cube and so on. So now we get this one. Now after simplification, we will get this one. Similarly, the third region is 0 less than mod z minus 1 less than 2. So which is equivalent to expand the function f of z in powers of z minus 1. So for that, you take u equal to z minus 1. Now the given inequality will become 0 less than mod u less than 2. So which also can be written as modulus of u by 2 less than 1. Similarly, mod u less than 2 implies mod u less than 1. We will see what we need in the problem. So the problem is expand the function f of z. So f of z can be written like this. So here you rewrite z in terms of u. So then what do we get? Z minus 1 is u. So you substitute here, then you get u minus 1 by u plus 1 by u minus 1. So first term you no need to do anything. So for the second term you bring it to the numerator, then you get 1 minus u whole power minus 1. This is like 1 minus x whole power minus 1 to x1. Then you get the required Laurent series expansion. That's all. Thank you.